Great, it's recording now. Section 3.7, derivatives of inverse functions. Recall, when you graph a function that is invertible together with its inverse function using the same xy coordinate system, the graph of the two functions are reflections of each other about this diagonal line y equal x, right? This is something that you learn from pre-calculus, right? So the graphs, again, mirror images of each other about this diagonal line y equal x. So it's like placing a mirror here. All right, but now we are doing calculus, so we should figure out how the derivatives of these two functions are related, right? Somehow. For that, notice here, the tangent line has been drawn for the original function and also for the inverse function. And notice that the tangent line are also mirror images of each other, right? About this diagonal line y equal x. They are reflections of each other. And that can be clearly seen when you draw a perpendicular here. You continue the same distance, right? For this point, there is a corresponding point over here, right? Very good. Or you can see also that this way, if you switch the coordinates of this point, here we have f inverse of a comma a, here you will have a comma f inverse of a, right? Switch. What is the input here becomes the output here, and what is the output here becomes the input here, right? Very good. Now, notice that if you now attach a right triangle having as a base point this on the tangent line, and you compute the slope of the tangent line as rise over run, notice this is the rise, this is the run, you get Q over P, right? Q over P. Now, if you do the same on this tangent line, the reflection of this original tangent line, right? Notice that the rise now is P, what was the run here, and the run is Q, what was the rise here, right? Somehow the slopes are reciprocal of each other, right? Reciprocals of each other. So the slope here was Q over P, the slope of the tangent line. Over here, the slope is P over Q, right? Reciprocals of each other. Now, this kind of gives us this hint, right? The derivative of the function and the derivative of the inverse function, between quotations, should be inverse of each other, right? Inverse of each other, or reciprocals of each other, better said, reciprocals of each other, right? But I say between quotations because this is when you do a computation at some input value, right? At some input value. If here the slope of the tangent line is Q over P, here P over Q. Reciprocals of each other. Try to keep that in mind. Now, we are supposed to figure out a formula to compute the slope of the tangent line for the inverse function, right? In other words, the derivative of the inverse function. So let g of x be the inverse function of a given function f of x. Then if you compose f with g in any order, the result should be the input value, right? Remember, we do the composition of a function with its inverse in any direction, the result is the input value, right? X. So now, taking derivatives on both sides of this equation, what are we gonna get? Well, notice that this guy is gonna play the role of the outside function. This guy is going to play the role of the inside function, okay? So applying our chain rule, derivative of this composite function will start with the derivative of the outside function evaluated at the inside function here, right? And then times the derivative of the inside function, right? The inside function. And all that should be equal to derivative of this identity function, which is just 1, right? 1. So now solving for g prime of x, which is going to be the derivative of the inverse function, notice I'm going to get the following. If I divide both sides of this equation by this guy, f prime of g of x, I'm going to get here, after canceling, g prime of x equal to 1 over f prime of g of x, right? So solving for g prime of x, what we're gonna get is this nice formula. Look, derivative of the inverse function is equal to 1 over the derivative of the given function evaluated at the inverse function, right? And this is a nice formula, right? That shows, right, how the derivative of an inverse function and the derivative of the original function are sort of reciprocals of each other, right? Very good. Okay, guys, so now, as an example of this formula, recall we work with this square root function, right? Square root of x. Suppose g of x equal square root of x. That is the inverse function of f of x equal x squared, right? So now let's use this formula and check if it actually works, right? What should be the derivative of this inverse function? Well, if you use this formula, that is going to be 1 over the derivative of the original function, this f of x equal x squared, which is just 2 times something raised to 2 minus 1, 1, right? It's right here, 2 minus 1, so I can follow. Evaluated at the inverse function, which is this square root of x, right? Now, if you do the math here, you can see that the derivative of the inverse function of x, the function x squared, square root of x, is equal to 1 over twice a square root of x raised to the first power, right? We don't have to write the one. And you can see here that this is indeed what we got as a result before, right? So the formula works, it's nice. It's a little bit theoretical, right? We're not gonna use this formula too much because we will develop formulas so that we can use the final results, but it's good to know, right? That how the derivative of a function and the derivative of its inverse function are related. Okay, so now we're gonna consider the development of derivative of inverse trigonometric functions, okay? Now, we are going to recall what is an inverse trigonometric function so we avoid confusion. Remember, if sine of pi over 6, which is converted to degrees 30 degrees, right, is equal to 1/2, remember, this inverse sine function, sine inverse of 1/2 is equal to pi over 6, right? Remember, guys, this is how the sine inverse function works, right? Sine of 30 degrees, 1/2, or sine of pi over 6 radians, 1/2, but sine inverse of 1/2 equal pi over 6, right? Equivalently, mathematicians have another notation for sine inverse is this: arc sine of pi over 6 equal arc sine of 1/2, right? Remember the output goes here. equal pi over 6, right? Pi over 6. It's the same. This arc sine is the same as the sine inverse, right? So do not confuse this -1 with exponent. It's just the inverse function of sine, right? Yeah. If you don't want to use this -1 on the top, use arc sine, right? So arc means angle, right? Maybe I should write here on the top. Arc means angle. All right, guys, with all this and with a little note here, note, this is not exponent, right? Not exponent. It means sine inverse, right? It means sine inverse, okay? We're gonna take derivatives of this guy, so don't take this as exponent, it's instead sine inverse. Okay, guys, so now let's talk about the derivative of sine inverse, right? The derivative of sine inverse. We are going to develop formulas for the derivative of these trigonometric inverse functions. So let g of x be equal to sine inverse of x. Let this be the inverse function of f of x equals sine of x. I'm going to apply the formula that says that the derivative of the inverse function is 1 over the derivative of the original function evaluated at the inverse function, right? This is what we showed before. So let's do that. So the derivative with respect to x, derivative with respect to x of sine inverse of x should be equal to 1 over, following this formula, right? 1 over the derivative of the original function, which is sine, right? Sine, the derivative of sine, which is cosine, right? Cosine, evaluated at g of x, which is the inverse function, sine inverse, right? Sine inverse. Let's write it in red, sine inverse. Okay. But now, what is this? Cosine of sine inverse. Let's find out, right? Let's find out what is that. Let theta represent this guy, sine inverse of x. Then we are looking for this 1 over cosine of theta, right? Of theta. But if we let theta be sine inverse of x, remember, then it means that sine of theta has to be equal to x, right? Sine of theta equal to x. But now x is the same as x over 1. And if we for a moment assume that our theta, our angle, is between 0 and pi over 2, acute angle, right? We can construct a triangle where the opposite is x, and the hypotenuse is 1, right? Remember, sine is opposite over hypotenuse. All right? But now we don't have the base. We don't have the base, not a problem, because using the theorem of Pythagoras, we can find our base, right? We can say b squared plus x squared equal 1 squared. So b squared plus x squared equal 1. And from there, subtracting x squared in both sides, I can find that b squared is equal to 1 minus x squared, right? And from there, since the angle theta is acute angle, this should be positive. B should be equal to square root of 1 minus x squared, right? That is B. Immediately put it here. And therefore, now I can compute cosine of theta, right? Which is something that I needed here to complete this, right? So this means that this guy should be equal to 1 over cosine of theta, but cosine of theta, looking at this triangle, should be b, which is this guy, right? B over 1 over b, but b is this guy in terms of x. So finally, look, 1 over the square root of 1 minus x squared, right? Finally, I got a formula for the derivative of sine inverse of x. It took a while, right? So a lot of mathematics there involved, but finally we got it. Look, this is it. Now, I may write a note here. Sometimes when I do this demonstration, students ask me, Professor, what if the angle is not between 0 and pi over 2? What if the angle is negative? Could be, right? But in this case, since there is a property that says that sine of minus theta is equal to minus sine of theta, the formula will still work. If you take the quotient, do what I did here, this negative sign will cancel with the negative sign that we will get when we work with this formula. You can check, right? Then the formula, since this is true, then the formula still holds. So it works for any value of x. The only value of x that is going to give us trouble is 1, right? But look at this construction, x can never be 1, right? If you're thinking of this right triangle. Yeah, but we will write it on the side. So conclusion, guys, conclusion, and I want you to, from now on, have this result, okay? So from now on, don't worry too much about the demonstration, right? But for us at this level, we should first know that the derivative of sine inverse of x should be equal to, we got it here, right? 1 over the square root of 1 minus x squared. For all x, except for 1 or negative 1, right? Because 1 squared 1 is going to give us 0 in the denominator, negative 1 squared 1 is going to give us 0 in the denominator. So this is a formula that you should have to keep in mind, guys. The derivative of sine inverse of x with respect to x, 1 over the square root of 1 minus x squared. Similarly, mathematicians figure out the derivative of cosine inverse of x. And it turns out it's very close to this formula, except for the negative sign here. So negative sign there, and the denominator is the same. So this is gonna be a second formula that we're gonna use heavily, okay? And again, for all x not equal to 1 or minus 1 in general, right? Okay, and mathematicians continue working. Notice sine of x over cosine of x is equal to tangent of x. So using that relationship, they figure out also the derivative of tangent inverse. And that is 1 over 1 plus x squared, okay? And this always works, even if x is 1 or minus 1, because notice I don't have problems on the denominator. This denominator can never be 0, right? At least will be 1, because this x squared is at least 0. So these three formulas will develop. Now for cotangent, very close to the formula for the derivative of tangent inverse. The derivative of cotangent inverse is minus 1 here, minus 1 on top, the rest the same, 1 plus x squared. Derivative of secant inverse, mathematicians figure it out, is equal to this. 1 over absolute value of x multiplied by the square root of x squared minus 1. Derivative of cosecant inverse, the same as this. The only thing that changes on the numerator, you attach a negative sign. Negative 1 over square root of x squared minus 1 times the absolute value of x. Very good. Now you may say, Professor, so many formulas to remember, right? 6 formulas here. Just gave us.
Yeah.
Guys, if you can, yeah, very good. It's a natural thing to say, right? So for you to remember these formulas, I have attached in our website, right, under course materials, important sheets, this set of formulas, right? They are all there. Look, the first one, derivative of sine inverse 1 over square root of 1 minus. Notice they have used parentheses here, then x squared, right? It's the same as x squared, but the reason why they put parentheses here is because in general, we are gonna work with composite function. So inside this parenthesis, you may not have x, you may have some other function, right? So it's just because of that. Derivative of cosine inverse minus is the opposite of this, right? Minus 1 over square root of 1 minus x squared. Derivative of tangent inverse 1 over 1 plus x squared. Derivative of cotangent inverse minus 1 over 1 plus x squared. Derivative of secant inverse 1 over absolute value of x, don't forget the absolute value, times the square root of x squared minus 1. And here it's opposite, right? They come in opposite pairs. Derivative of cosine inverse minus 1 over square root of x multiplying square root of x squared minus 1. So have this. Maybe I can give you directly the link if here in the chat, so you can save this link, or you can look at in our websites there, right? This is the link for the PDF. And also I posted this set of basic formulas, right? This one's probably you memorize it to them already, right? Derivative of sine cosine, derivative of cosine minus sine, derivative of tangent secant squared, derivative of cotangent minus cosecant squared, derivative of secant times tangent, derivative of cosecant minus cosecant multiplied by cotangent, right? So both you have them. I want to send you the link of this one too. So print this out, have it around, right? When you take your exams, when you do your homework, so in case you cannot memorize them, right? Especially the second set, right? It's kind of long. Yeah, let me send this one too, just in case. We're gonna use them a lot heavily today. All right, so now examples, right? Our interest is should be focused on using this formula, right? The demonstration, I did it for the first one. You saw it's mathematically heavy, right? Abstract. But again, at this level, guys, you should just make sure that you know how to use these formulas, right? For the case of composite functions. I'm gonna go over a lot of examples. And remember, don't confuse this negative one with exponent. This means inverse function, right? Inverse function. All right, so let me give you this first example, and then we will go over the worksheets. We'll go over different forms so you can master this topic. Example 1. Suppose they ask you to figure out the derivative of this composite function, f of x equal tangent inverse of x squared. And once you do that, evaluate the derivative of this composite function at the input value x equal to. Solution. Solution start by clearly identifying the outside function and the inside function, right? This is a composite function. This is not x, is x squared, right? So I'm going to use blue to identify clearly my inverse function, which is my outside function, which is this tangent inverse, right? My outside function, and red to identify clearly my inside function, x squared, right? X squared. So outside function tangent inverse, inside function x squared. So let's apply our chain rule in its second form, right? The derivative of this composite function should be the derivative of the outside function, derivative of this tangent inverse. But remember, we just said that the derivative of tangent inverse is 1 over 1 plus something squared, right? That's why they place parentheses. And Yeah, very good, Gonka, very good, excellent. We're headed there. Yeah, so now what goes inside the inside function x squared, right? Professor, how do you know derivative of tangent inverse is 1 over 1 plus x squared? In case, guys, you cannot remember this, just pull out your sheet of formulas here, right? I'm using this one. And you can see here how this parenthesis help, right? This parenthesis help. So you place inside the inside function. All right, now continue doing the math here, simplify as much as you can. Don't forget that you have to multiply this by the derivative of the inside function, right? We're gonna write it here like this, derivative with respect to x of this x squared. And by the way, what is this derivative? Anybody could tell us in the chat? Derivative of x squared. Very good, guys. Very good. Yeah, I'm glad that you remember. Twice Marcos, very good, Robert, right? Twice x, this guy, right? Twice x. So we are gonna have finally 1 over 1 plus x squared squared. Remember, you multiply the exponents, 2 times 2, 4, times this derivative, twice x, right? Now, twice x times 1 is twice x, right? Twice x, or 2x, over 1 plus x to the 4th power. This is it. Now, besides the computation of the derivative, in general, they want you to evaluate your derivative at x equal 2, right? At x equal 2. Not a problem. Then we can say that the derivative for composite function evaluated at 2 should be just this, right? 2 times 2 over 1 plus 2 raised to the 4th power, right? I have substituted x with 2, and I'm going to do the computation now. 2 times 2 is 4. 2 raised to the 4th power is 16 plus 1, 17, right? So that's it. This is my answer.
Oh, I made a mistake, Professor. I plugged 2 in the first f of x without f prime. So I'm sorry.
Yeah, but it's okay. It's okay.
I didn't even listen the whole thing. Sorry. When I saw the numbers.
No, it's okay. It's okay. Yeah, this prime was indicated as derivative, right? Derivative. Yeah. So once you get your derivative, then you do the evaluation. Yeah, very good, very good.
Thank you.
Very good, Gonka. Yeah, very good, guys, that you are clearing things up, right? This is what the lecture is for. We clear things up here so that when we move forward, everything should be crystal clear. All right, that was the first example. So I'm gonna let you practice and then we will do the same here with the product rule, okay? So let me go over the worksheets now for you to see how this is gonna be evaluated or tested. I'm gonna do number 1. And then I will ask you to do number 2, okay? Let me do number 1. Suppose they say, okay, y equal 3 times sine inverse of 5x to the 4th power. And they want you to figure out its derivative. All right, so what should be the derivative of this guy? Well, notice that there is a number 3, which is a constant. You shouldn't worry about that because constant can be taken outside of the differentiation, right? But I should worry about what is the outside function and what is the inside function. Look, clearly here, sine inverse is the outside function, right? And the inside function is just this 5x to the 4th power, right? Very good. So now, the number 3, I shouldn't worry about it because I can pull this out. Outside the derivative, right? So the derivative, y prime or dy dx, same idea. It's going to be 3 times derivative of the outside function, derivative of sine inverse. But recall, we said that the derivative of sine inverse with respect to x is just this 1 over the square root of 1 minus x squared, right? And in case you don't remember that, there is a sheet with that where that is stated right here. This is right. Okay, great. So now this is our first step. 1 over the square root of 1 minus something squared. But what is that something squared? This, the inside function, right? You leave this alone here. 5x to the 4th. Now, times, don't forget that then you have to multiply this by the derivative with respect to x of your inside function, which is this, right? Yeah, and by the way, what is this? Anybody could tell us in the chat, what is that derivative here? Or verbally? Very good.
20x cubed.
20x cubed. Excellent, excellent, excellent. And here someone wrote it here. And Marcos also, very good, very good. 20x cubed. Yeah, 20x cubed here, right? 20x cubed times 1 over a square root of, here you have to remember your algebra, 5 squared, 25, x to the 4 squared, multiply 4 times 2, x to the 8, right? X to the 8, very good. Almost done here. Now, this is gonna be equal to 20x cubed times 1 is just 20x cubed, right? Over a square root of 1 minus 25x to the 8th power, right? To the 8th power, and don't forget that there is a 3 here, so 3 times this should be 60, right? Yeah, 60, this 3. Maybe we should put it here. Yeah, 3 times 1 times 20, 60, 60. Very good. Okay, so this is the answer. Let's write it nicely, 60x cubed over this, right? Which is the first one. Very good. Can you try now number 2? I'm gonna leave this for you to have as a reference. Can you try this? And I will write here the formula. Recall the derivative of cosine inverse of x in general with respect to x is equal to 1 over minus the square root of 1 minus x squared, right? Put the minus on the top or on the bottom, doesn't matter. Yeah, very good. Yeah, can you try this? And hint, when you square the inside part, leave it alone, don't expand, just leave it alone, okay? I see activity, the chat room. Agonka, very good, very good. Excellent. Yeah, you made my day. Marcos also, very good, guys, very good. Yeah, I think you are tuned. Very good. It's not that difficult, but as long as you remember this, or you can have it from your sheet of formulas that I gave you, right, on the chat. It's also on our website. Okay, so let's do it together. First, write out y equal cosine inverse of 5x squared minus 4, and clearly identify your outside function. In this case, this is the cosine inverse function, and your inside function, which is this 5x squared minus 4, right? Minus 4. Now the derivative of y with respect to x, right, will be derivative of outside function according to the chain rule. Derivative of this guy is this, right? Minus here 1 over the square root of 1 minus something squared, right? Something squared. That something is this inside function, 5x to the 2nd power minus 4 times the derivative of your inside function. So anyone could tell us what is the derivative of the inside function here? This? Either verbally or in the chat.
10x. 10x.
10x, right? That's it. Derivative of 4, 0, right? Excellent, excellent. Okay, here. German, Robert, Marcos, very good, guys. Very good. Excellent, right? So now this is going to be negative 1 over a square root of 1 minus. Remember the hint, do not expand this, leave this alone. Okay. Times 10x, right? 10x is the derivative. Then just put things together. 10x times negative 1, negative 10x, all over 1 minus 5x squared minus 4 squared. And that should be it, right? That should be it. When you look through the choices, this is it, right? This is it. Very good, guys. Very good, excellent. Now, there are some tricky cases here, such as this, where you have to do some algebra, some heavy algebra. I will show you. Let me show you more examples, and we will come back to this, right? And then we will use also product rule. Yeah, maybe I should show you this one for tangent inverse, and let me see. And there is one for cotangent inverse here. Yeah, let me see. Yeah, I can show you the one for tangent inverse, and you can do the one for cotangent inverse. Okay, let's do it. Let me show you this. Sometimes the algebra will be heavy, but just remember how to multiply fractions, how to divide fractions, and how to even add fractions, and that should be enough. So y equal tangent inverse, allow me to write it like this, of 4x over 5, right? This is the function. They want you to figure out the derivative of this function, right? Let's call it y prime for the sake of variety on the representation of the derivative this time, y prime. They want you to figure out the derivative. Well, take tangent inverse as your outside function and 4x over 5 as your inside function, right? Now start with the derivative of the outside function. The derivative of the tangent inverse is 1 over, remember, 1 plus something square, right? Something square. So I don't remember the formula. It's here. The derivative of tangent inverse 1 over 1 plus x squared. Excellent, excellent. Someone wrote something on the chat. Yeah, yes, yes, Gonka. Let me clarify this, okay? Yeah, let's write it here. There is this issue with the inverse, right? Maybe I can write it here somewhere on the side. Yeah. Note. Sine inverse, let's say, of pi over 6. What is this? Sorry. Sine inverse of, not pi over 6, 1/2. Sine inverse of 1/2 is the angle whose sine is 1/2, right? Whose sine is 1/2. This is pi over 6, which is 30 degrees, right? This is the same as arc sine of 1 over 2. The arc, the angle whose sine is 1/2 is pi over 6, right? The output of this always in radians, but this pi over 6 is the same as in degrees. So this is not exponent. Instead, it tells you about the sine inverse function, right? Now it's better, okay?
Yes, thank you.
Okay, very good. Very good. Yeah, do not confuse this with sine with -1. It's not 1 over sine of 1/2. No, it's sine inverse, right? Yeah, very good. So now here, right, this is the derivative of the outside function, and this should be multiplied by the derivative of the inside function, 4x over 5. But anyone could tell us what is this? This derivative. Derivative of 4x over 5. Try to find that while I write this down. 1 plus. Remember, hint, when you have this, just look at the constant part, right? This is what it is, because the constant comes outside, the derivative of x is 1, so 4/5.
4 over 5.
4 over 5. Excellent, okay. 4 over 5. That's it, right? Yeah, that's it. 4 over 5. So we agree that this guy is 4 over 5. We're going to do this carefully. Now, this 4 over 5 must multiply all this, right? Now, when you square this part, 4x over 5 squared, that's going to be 4 squared 16, x squared over 5 squared 25, right? 25. Very good. Now, carefully, I'm going to do this. Now, the derivative y prime will be equal to what? 1 over 1 plus, notice that this 1 is the same as 1 over 1, and that I have to add to 16x squared over 25, right? And all this multiplied by 4 over 5. But now, notice, guys, 1 and 25, they have LCD 25, right? So you multiply numerator and denominator by 25, and you get this nice expression. As I advertised, right, a lot of algebra is needed here, but do it carefully, and they should come out the answers of this, right? Now, when you add, you keep the denominator, common denominator, so you're gonna get this. 25 plus 16 x squared all over 25 here, right? Close to the end. Now, remember, when you divide by a fraction, you multiply by the reciprocal of the fraction, right? You flip this and you multiply, right? So what's going to happen here is this. This is going to be 25 on the top, 25 plus 16x squared, right? Because you flip and you multiply by 1, this is what you get, times 4 over 5. Don't forget this. Now, 5 into 25 is just 5, right? And 5 times 4, isn't it 20? 20 over 25 plus 16 x squared. Yeah, excellent. So this should be the final answer, right? After some heavy algebra there, but if you follow again all the steps, you should end up here, which is the answer, and it's there here. Choice B. Follow, guys? Yeah. Now, doing or following this technique, can you try this one? I'll give you some time. So y equal negative cotangent inverse of 8x over 7. Hint, the negative one, don't worry about that. You can pull it outside, right? Outside of the differentiation, outside of the derivative. So don't worry about this negative. But then set this to be your outside function. And set this guy inside to be your inside function, 8x over 7. Okay? Yeah, try to get the derivative of y with respect to x. And maybe I should write here, recall, right, in case you forgot. Recall the derivative of tangent inverse of x with respect to x is just 1 over 1 plus x squared, right? This is for you to get the derivative of that outside function, but I think we need cotangent. So let me write here cotangent. The derivative of cotangent inverse is minus 1 over 1 plus x squared. This is what we need here. And then use your algebra, right? Aha, let's see. I think the students figure this out. Aha, Marcos. Yeah, very good, guys. Yeah, Marcos, also Gonka. Very good, guys. Very good. Excellent. Yeah, you made my day. Excellent, excellent. Yeah, again, it's not that difficult as long as you remember how to work with fractions, right? Dividing by fractions, adding fractions. All right, so let's do it together. The negative sign should come outside of the derivative, right? Outside, and then you focus on taking the derivatives of this composite function. Derivative of cotangent inverse is this minus 1 over 1 plus something square, right? Something square. But is that something? The inside function, right? Ax over 7. That's why in the formulas they put this parentheses to help you out with that. Right, times the derivative of this. But what is the derivative of this guy? 8x over 7. Anybody on the chat with respect to x? What's this derivative?
8 over 7.
8 over 7. Excellent. Okay, 8 over 7, right? You just focus on the constant part, right? That's it. Very good, very good. 8 over 7 here. Times, right? Negative and negative, positive, right? Positive. So this is going to be just 1 over, this is this 1 over 1 plus 8x squared. 8 squared, 64, right? 64 x squared. 7 squared, 49, right? 49. What is left is just to do the algebra here, right? Now notice this 1 is the same as 1 over 1, right? LCD for 1 and 49 is 49, right? So you multiply by 49 top and bottom. So you get 49 here, 49 here. So common denominator should be 49, right? 49. And here you get 49 plus 64 x squared. And here 1, right? Here 1. This is the what we got when we simplify, right? Now, this should be multiplied by is a over 7, right? By a over 7. Now, when you divide 1 by this fraction, remember, you flip the fraction and multiply by 1. So that's going to give us 49 on the top, 49 plus 64 x squared on the bottom, times 8 over 7. Now, 7 into 49 is 7, right? 7. And 7 times 8 is just 56, right? 56. All over 49 plus 64 x squared. Excellent, excellent, guys. So this is it. And this is posted here. Right? Very good, very good. All right, guys. So now let me show you what to do when they give you the multiplication of a function times a trigonometric inverse function. Something that will help us with this form, for example, right? These forms. So let's go back to the notes. Okay, so example 4, I think example 3. Example 3, example 2. Yeah, example 2. Suppose they give you this function h of x equal x squared times sine inverse of x, and they ask you to figure out its derivative. And clearly here we must use the product rule, right? The product rule. So let's see. Let's start by saying, okay, this function h of x is equal to the function x squared multiplied by the function sine inverse of x, right? So let's call this guy f, let's call this guy g, and let's apply our product rule, right? Our product rule, which is this, right? Recall the derivative of f times g is derivative of f times g plus derivative of g times f, right? Let's use our product rule. So the derivative of the function h will be derivative of f, which is just twice x, right? Times the function g as it is, this, right? Plus derivative of g, derivative of this guy. But the derivative of sine inverse, remember, is 1 over a square root of 1 minus x squared, right? That times the function f as it is, x squared. Now, if you don't recall this, I show you guys in our website, we have these results, right? derivative of sine inverse 1 over square root of 1 minus x squared. All right, great. So now just simplify. So h prime of x, or derivative of the function h, will be 2x multiplied by sine inverse of x. X squared times 1 is just x squared over the square root of 1 minus x squared, right? There is nothing else to do there. Just leave it alone. This should be your answer, okay? All right, based on this, probably you should try this on the worksheet. This one. Can you try this? Number 4, and then we will take a break. So try to do this. Do y equal 4x cubed sine inverse of x. Hint, call this your function f, call this your function g, and recall that the derivative of f times g is equal to f prime g plus g prime f, right? Recall that, figure this out. Go ahead. And also recall that the derivative with respect to x in general of the sine inverse function is just this, 1 over a square root of 1 minus x squared. So use these two. Together with a product rule and figure this out. And try to remember this for your homework or problems. They will ask you to combine the product rule with this new set of formulas that we got, right? I see for number 4. Marcos, very good, very good. Good work. Excellent, excellent. Yeah, very good, very good. Also, Gonca, very good, deep. Yeah, I'm glad, guys, that you are following this. Yeah, so what should be the derivative? Well, the derivative of this function, y prime, should be, start with derivative of f, right? Which is just 3 coming down, multiplying for 12x raised to 1 less 12x squared, times the g function as it is, right? Times the g function as it is, which is this sine inverse of x, plus the derivative of g. But the derivative of sine inverse, we said, is this 1 over the square root of 1 minus x squared, right? Times the function f as it is, 4x cubed. And what is left is just to simplify this as much as you can, right? So 12x squared multiplied by sine inverse of x, 4x cubed times 1 is just 4x cubed over a square root of 1 minus x squared, right? That's it. Look through the choices and it should be there. Indeed, it's the last choice, this one, right? Very good. They just wrote this first, this following, all about, okay. Sometimes when you go over your homework, you're going to encounter this notation, arc cosine, right? But what does it mean, Professor? Arc cosine. Well, mathematicians call arc cosine to cosine inverse. So if you encounter arc cosine, it's just cosine inverse. It's this function, right? And you may say, why they call arc an angle? Well, it has to do with trigonometry, right? When you remember in the unit circle, the angle is this is one times the angle is the arc, right? So there's a one-to-one relationship between the length of the arc and the angle. That's why they use this word arc, but this just means cosine inverse. So if you see this there, just use cosine inverse and everything comes back sort of to normal because we know what to do here, right? Identify your outside function as cosine inverse, your inside function as 3x minus 1. And when you take the derivative, you should start by taking the derivative of the outside function, derivative of cosine inverse, right? That is 1 over, with a negative sign here, 1 over the square root of 1 minus x squared, right? But this is not x, it's 3x minus 1. So let's write here a parentheses. We're gonna write the inside function, or the inside function here, and square it, right? Square. Yeah, and the chain rule says that must be multiplied by the derivative with respect to x of 3x minus 1, right? And what is this derivative? Anyone on the chat? What's the derivative of 3x minus 1? While I write this out.
3.
3, right? Yeah, very good, guys. That has to be crystal clear, right? The derivative of polynomial functions should be really, really clear. It's gonna be done so much in this course, right? Yeah, so very good. Excellent, Marcos. Yeah, that's just 3, right? The derivative of this guy is 0. All right, then do the math, and then you will end up with this. Y prime will be equal to 3 times negative 1, negative 3 over the square root of 1 minus 3x minus 1 squared, right? Square, and that should be it. Now, this negative sign, often mathematicians place it here in the middle. So don't be surprised if you encounter this negative sign right in the middle here. It could be placed on the top, in the middle, in the bottom, but very, very often mathematicians prefer to post it in the middle, right? Yeah, very good. All right, so now let's go back to the worksheets, right? Let's go back to the worksheets. And let's see if we can do more. Let's have this, we did this. Let's do one with cosecant inverse, but for that, let me explain to you how this works. Let's do one with secant inverse here. All right, suppose they ask you to figure out the derivative of secant inverse of 2x plus 5 divided by 7. We're gonna use a lot of algebra here, but again, if you do it carefully, you should end up with the right answer. Okay, and the absolute value function will be involved. Okay, so let's see. Solution here, identify clearly what is your outside function and what is your inside function, right? So let's mark in blue the outside function, secant inverse, right? Secant inverse. Outside function, inside function, 2x plus 5 over 7, right? Inside function. Yeah, very good. So now let's use our chain rule. Our chain rule says that the derivative of these composite functions should start with the derivative of the outside function, derivative of secant inverse. But what is that? Well, recall that the derivative of secant inverse of x with respect to x is just this, 1 over absolute value of x multiplying a square root of x squared minus 1, right? This is the derivative of secant inverse. In case you have trouble memorizing this result, look at the sheet of formulas. It's here, right? Derivative of secant inverse, look, 1 over absolute value of x times the square root of x squared minus 1. The x is written within parentheses, kind of to help you recall that you may not have x here, you may have some other function, right? Because you may be dealing with composite functions in general, right? Okay. All right, so let's use the formula then. Derivative of secant inverse will be 1 over the absolute value of x, but since I have this as my inside function, instead of x, I have to write here my inside function, right? Over 7 here. Very good. Times the square root of, here parentheses something squared minus 1. That something is your inside function. 2x plus 5 over 7 times the derivative with respect to x of the inside function, 2x plus 5 over 7. And by the way, anyone could tell us what is this derivative while I rewrite this? Yeah, very good, guys. I see. Robert, yeah, you made my day. Go also 2 over 7, right? 2 over 7. Not hard to see that if you distribute the division 7 into 2, 7 into 5, this will be 2x over 7, derivative of that 2 over 7, derivative of this 5 over 7, 0, right? 0, nothing. So this is very good, guys, very good. 2 over 7. Yes. Here. Now, here, guys, you have to apply some algebra. When you take absolute value, the absolute value of the numerator should be just this, absolute value of 2x plus 5, right? Because I don't know what is the value of x. If x is positive, probably this will be positive, right? But if x is negative, depending on how negative it is, this might end up being negative. So I don't know the sign of this guy. So leave the absolute value there. Absolute value of 7, however, since I know that 7 is a positive number, is just 7, right? 7. Good. Now over here, we have to do the following. Numerator 2x plus 5 is squared. Denominator 7 squared, but 7 squared is just 49, right? 49 minus 1. Now 1 is the same as 1 over 1, right? LCD 49 for 1 and 49. So multiply by 49 here, multiply by 49 here. Yeah, do this algebraic stuff carefully so we don't make any mistakes, right? So derivative will be equal to what? Look at this guy. I'm gonna sort of show this. Look, 1 over this, remember? This up here, this down here, dividing by a fraction is equivalent to multiply by the reciprocal of this fraction, right? So 1 times 7 over this, right? So that will be 7 over absolute value of 2x plus 5 times this part. This part, look, I have here 1. This part will be a square root of this guy squared minus 49, right? Let's write it. The square root of this guy 2x plus 5 squared minus 49. On the bottom, a square root of 49, but the square root of 49, isn't it 7, guys? 7. So you're very clear with this. Yeah, I know. I kind of skip one step there. Yeah. So, but again, right? When you subtract these two, this is what goes on the top. 49 goes on the bottom. Big square root. When you take a square root of the numerator, is this. When you take a square root of the denominator, a square root of 49 is the 7, right? Is the 7 here. But good news, this 7 here appears again up here. So whenever that happens, I should feel free to remove them, right? Cancel them. This, cancel with this. Okay? On the top, on the bottom. Now what is left? 2 times 1 times 7. 2 times 1 times 7, 14, right? 14. So 14 will go on the numerator, 14. On the denominator, what do I have? Absolute value of 2x plus 5 times the square root of, a big square root here. Keep it in exponential form, factor form, right? Don't expand, just leave it alone. Minus 49. And this should be it. This should allow you to identify your answer among the choices, okay? Okay, yeah. This part a little bit crazy, algebraically speaking, but just take the square root of the denominator is this cancels with this. All right, so now let's go back to the worksheet and let's see if you can do something similar. Going back to the worksheet, guys. There is one with cosecant here, so we can finish this worksheet. So go to the next worksheet. Number 6, can you try number 6? I will give you some hints. Y equal minus cosecant inverse of 8x plus 9 all over 3. Hints here. Recall the derivative of this function cosecant inverse is just minus 1 over absolute value of x multiplied by x squared minus 1, the square root of that. Right? Use this. And do not worry about this -1. This will come out, right? It's a constant, right? -1. So instead, focus on getting the derivative of this composite function. Outside function cosecant inverse. Inside function 8x plus 9 over 3. So 8x plus 9 over 3. Right? So try guys. The negative again comes out. Figure out the derivative of y prime or dy dx. Yeah, maybe I can put this in if you want to check the formulas. Yeah, it's written there, right? But the formulas, save this link. I gave it to you in the chat, right? So save it somewhere or print this out, have it next to you on your desk, or when you take your exam, when you do your homework, you will have this result handy. I see some activity on the chat room. Let's take a look at this. Number 6. Conga, excellent. Yeah, you made my day. Excellent. Very good, very good. Yeah, very good, very good. Excellent. Yeah, algebraically heavy, right? But it is what it is. And this will help you, again, a lot with your homework problems. So let's do it together and nicely, right? And slowly. All right, so remember the negative sign is not a problem because you can pull it outside the differentiation as well as the derivative, right? It's a constant. We focus on taking the derivative of this composite function, right? Cosecant inverse of 8x plus 9 over 3. Now, derivative of cosecant inverse is this, right? Cosecant inverse of x. So we're going to start by writing here 1 over the absolute value, but the absolute value what? The inside function, right? Inside, because remember, this is not cosecant inverse of x, it's cosecant inverse of 8x plus 9 over 3. So the chain rule says that you have to keep the inside function here, right? Times a square root of something square, but that something is the inside function, right? 8x plus 9 over 2 square minus 1. All these times the derivative with respect to x of the inside function, 8x plus 9 all over 3. And by the way, anyone could tell us what is this derivative? Derivative of the inside function?
8 over 3, Professor.
A
You
over
wrote-
3.
Yeah,
Excellent.
you wrote it wrong on that square root of part. 8 over 2, you said you did. No.
Here,
Yeah.
right? Yeah, nice catch, Gonka, nice catch. Thank you. It's a little tail was missing there. Yeah, A over 3. Yeah, very good, guys. Very good, excellent, right? Yeah, excellent. Yeah. So derivative of this, excellent, okay. Yeah, and let me, sometimes students, when we state that this derivative is A over 3, say, why is that? Well, if you distribute the division, right, we said this is 8x over 3 plus 3 into 9 is 3, right? So when you take the derivative, indeed, this is the one that matters, right? A over 3, very good. The derivative of this, 0, right? 0. So this whole thing, A over 3, excellent. Yeah, note here. All right, so this A over 3, excellent. Times, now let's work this out, but also don't forget to the negative sign here, right? There's a negative sign there. So don't forget this. Negative times negative is going to be positive, right? Positive. So don't worry about this, two negative and positive. One on the top divided by what? The absolute value of 8x plus 9 over 3. Absolute value of 8x plus 9 cannot be simplified because we don't know what is the value of x, right? If x is positive, will be just itself, but if x is very negative, this could be negative, right? We don't know, so leave this alone, leave the absolute values there. Now, the absolute value of 3, however, since 3 is definitely a positive number, it's just 3, right? Yeah, now, times this, the square root of this guy squared, 8x plus 9 squared over 3 squared, but 3 squared is just 9 minus 1. But this 1 is the same as 1 over 1. LCD for 1 and 9 is just 9, right? So this is it, right? Yeah. Now, remember, when we divide 1 by a fraction, we are supposed to flip the fraction on the bottom, right, and multiply by 1. The result of doing that is going to be just this. Y prime will be equal to 3 on the top and this one on the bottom, right? Yeah, I hope you guys follow that. Yeah. Flip it, right? Yeah, maybe I should put here this so you will identify this with this. Now here, there is nothing, there's an invisible 1 there. So keep your invisible 1 there. Now notice this is square root has inside 8x plus 9 squared minus 9 on the top. On the bottom, this 9, right? This 9. But when you take the square roots, this is going to be the square root of this piece over the square root of 9. But the square root of 9 is just 3, right? Square root of 9, 3. This must be multiplied by 8 over 3. Notice, guys, that this number 3 on the bottom cancels with this number 3 on the top, right? It's just a property of the derivative of this form, right? These two guys, they cancel. On the top, I will be left with 8 times 1, 8 times 3, 24, right? 24 on the top. On the bottom, absolute value of 8x plus 9 times the square root of 8x plus 9 squared minus 9, right? Minus 9, and that's it, right? That's it. Looking through, you should be able to find your answer there. Your answer there, which is the first one, right? The first one, this one. Yeah, one with the absolute value here. Excellent. Very good, guys. Okay, so now let's go over other forms. Let's just make sure this stays there. And let's go over other forms. Okay, very good. There's another worksheet here. We're gonna try to do some of this, okay? Let's start with the one with a product rule. I gave you an example, right? So probably we can work this out. Let's try number 2. Can you try it? Hint, identify this guy with F and identify the sine inverse of X with G. Yeah, it's application of the product rule, and then we'll go over these tricky cases there. And recall that the derivative with respect to X of sine inverse is 1 over the square root of 1 minus X squared. And the product rule is just this, F prime G plus G prime F, right? So try to do this, guys. Let's check. There are 2 students who have posted answers. Very good for number 2. Very good. Very good, Marcos. Very good, Gonka. Excellent, excellent, excellent work, guys. Yeah. Product rule, right? Product rule together with our formula to compute the derivative of sine inverse. Okay, so y prime should be equal to what? Start with the derivative of f. The derivative of this is just 4 coming down, multiplying 4, 16. 1 less stage, right? 16 times x cubed times the function g as it is. This is the function g plus derivative of g, but the derivative of this is just this, right? Plus this 1 over square root of 1 minus x squared times the function f, which is this, right? 4 x to the 4. Simplifying, this just ends up being just this 16x cubed sine inverse of x plus 4x to the 4 power times 1, 4x to the 4 power over a square root of 1 minus x squared, right? And that's it. Look through the choices and you will see that this is the answer, right? This is here, this is here. Very good, guys. So now I'm going to show you some tricky forms. For example, this form where the inside function comes as 1 over something. I'm going to do number 3, and then I will ask you to do number 4, okay? Let me show you this. Suppose they say compute the derivative of this function, sine inverse of 1 over x to the 4. When you see this right away, advice, rewrite this 1 over x to the 4 as x raised to minus 4. In other words, put this up here, right? Why are we doing this? Well, because I want this power form, so you can use the power rule, right? Power rule. Next step, identify clearly what is your outside function and what is your inside function. Outside function sine inverse, inside function x raised to minus 4. Next, take the derivative using the chain rule. Chain rule says start with the derivative of the outside function. The derivative of this outside function sine inverse is this, 1 over the square root of 1 minus something squared. That something happens to be the inside function, right? This. Times the derivative of the inside function here. with respect to x. And by the way, what is this derivative? Anybody could tell us while I write this out? This derivative of x raised to minus 4. I see. Let's check. Minus 4 times x raised to minus 5. Very good, Marcos. Very good, Deep, right? That's what it is, right? That's what it is. Excellent. And that's the reason why we wrote it this way, right? Yeah, so we can compute this derivative easily. So let's just write it out. Minus 4 times x raised to minus 4 minus 1 is minus 5. This is it. Now, over here, the derivative of the outside function evaluated at the inside function leads to the following. X to the minus 4 raised to the second power, x to the negative 8. Negative 8 there, right? Very good. You got this. Now, somehow algebraically, we have to figure this whole thing out. Okay, so what you do is this, right? Y prime will be equal to what? 1 over here. Rewrite this as 1 minus 1 over x to the 8. Okay, put this down. Will help us with the computation, you will see. 1 is 1 over 1. Take the LCD of 1 and x to the 8, that is x to the 8, right? Times x to the 8 times x to the 8 here, right? Now, this guy over here, I have minus 4 times 1 over x to the 5th power. Keep it there. Work this out. Y prime will be equal to what? The top, the numerator should be this. 1 over a square root of x to the 8 minus 1, right? Minus 1. The numerator should be the square root of x to the 8, right? The square root. Maybe I should write it so nobody gets confused. Yeah. One extra step we'll take. And here I have negative 4 times 1 is negative 4 over x to the 5th. Now, check this out, guys. The square root of this guy is going to be x to the 4 power, right? Because x to the 4 power is positive. So x to the 4 power, I'm dividing the index 2 into 8, right? So that's going to be that. So 1 over square root of x to the 8 minus 1 all over x to the 4 power. But now notice that that x to the 4 power can be simplified with this x to the 5th power. Look, f to the 5th power divided by x to the 4th power is just x, right? Subtracting the exponents. So that x is what I'm going to put it up front here. Negative 4 times 1, negative 4, right? And on the bottom, look, this is the numerator. On the bottom, look, x to the 5th divided by x to the 4, yes, x, multiplied by a square root of x to the 8 minus 1, right? And that's the one that you have to look for. Is here for number 3, right? I think it's this one. Yeah, you see it, guys? Yeah, some crazy algebra there, right? But again, simplifying, you will end up with this, right? Can you try number 4, this one? I'm gonna leave this there so you can see it as a reference. Try this. And remember that the derivative of cosine inverse is just negative 1 over, I will write it here, recall. Derivative with respect to x of cosine inverse equal minus 1 over the square root of 1 minus x squared, right? It's very similar to the derivative of sine inverse, but with a negative sign there. Yeah. Yeah, then rewrite this as, yeah, maybe I should give this hint. Yes, heavily algebraic, this problem. Deep figure this out. Let me see. Deep, yeah, excellent work. Yeah, very good. Yeah, probably an extra hint should be this, right? When you see this expression, 1 over some power of x, it's better to rewrite it this way. cosine inverse of x raised to minus 2, right? So we're going to use the power rule to get the derivative of our inside function, right? Yeah, and the second hint should be the negative sign. Don't worry about that because it can be pulled outside the differentiation, outside the derivative. Focus on this derivative, the derivative of this composite function. The one having outside function cosine inverse and inside function x raised to minus 2. This form, guys, is going to help a lot on your homework. All right, yeah, this is inside function, right? Yeah, try. Number 4. More students posting answers. Marcos, very good, excellent, very good work. Algebraic is heavy, but if you go through all this, you will end up with the final answer, right? Yeah, let's do it together so we can check last form. The negative sign should be a problem. It's just a constant that I can pull outside the derivative, so this is minus. I focus my attention on taking the derivative of this composite function, right? The derivative of cosine inverse is this minus 1 over the square root of 1 minus something square. But that something happens to be our inside function, right? X raised to negative 2 times the derivative with respect to x of our inside function, which is x raised to minus 2. And by the way, guys, what is this derivative? Anybody could tell us on the chat?
2 over x cubed.
Negative 2 times x raised to minus 2 over, yeah, excellent, 2 over x cubed.
Yes, sorry.
Yeah, negative 2 over x cubed. Very good. Okay, all simplify, right? All simplify. Excellent. Yeah, because this guy initially is going to be negative 2 times x raised to negative 2 minus 1, that is negative 3, right? But somehow negative and negative positive, don't worry about the sign. Somehow it will be useful to rewrite it this down here, right? So we will do that. Very good. So notice here, x raised to negative 2 raised to the second power, x raised to negative 4, right? X raised to negative 4. So next step here, carefully, this y prime should be equal to 1 over the square root of 1 minus 1 over x to the 4 times negative 2 over x to the third, right? As Gonka pointed out. Very good. But now multiplying these two guys on the top, we'll be left with negative 2, right? On the bottom, however, look, notice this guy is 1 over 1. LCD of 1 and x to the 4 power is x to the 4 power. So we multiply by x to the 4 power numerator and denominator. And here we're going to get the following. 1 times x to the 4 minus 1 on the top. And on the bottom here, x to the 4, right? X to the 4. This times, since we multiply this negative 2 times 1, what is left here is just 1 over x cubed. 1 over x cubed. We're close to the end. And now remember, y prime should be equal to what? Negative 2 over the square root of x to the 4 minus 1 over the square root of x to the 4. But the square root of x to the 4, x to the second, right? X to the second. And don't forget, times 1 over x cubed. X cubed divided by x to the second is just x. This simplifies to x. That x, I'm going to place it up front. So y prime will be minus 2 over x, the result of dividing these two, times the square root of x to the 4 minus 1, right? And that should be it, right? That should be the final answer. And it's here. Right? Mm-hmm. Very good, guys. Mm-hmm. Excellent. Now let's go over the last form, which is this one, 5 and 6. I'm going to do number 5. I'm going to let you do number 6, okay? For number 5, they're asking you to figure out the derivative of this composite function, y equal tangent inverse of, allow me to use parentheses here, of the square root of 5x. This form is a little bit special because in reality, this is a nested function made of 3 functions. 3 functions, Professor. What are the 3 functions? Well, the first function, the outsidemost function, is tangent inverse, right? Tangent inverse, the outsidemost. After that comes the square root function, this. And after that comes the 5 times x linear function, right? So 3 functions here composed. So we gotta be careful here. So start your derivative with the derivative of the outsidemost function, which is tangent inverse, right? Tangent inverse. Well, what is the derivative of tangent inverse? That is 1 over 1 plus something square. Something square, Professor, how do you know? Well, I have memorized this formula, right? But if in case you have not, here it is, right? Derivative of tangent inverse, I'm using this 1 over 1 plus parentheses x squared. But this x is often some other function, right? In this case, it's this function, right? Let's write it inside. So this is going to be a square root of the function is the square root of 5x, right? Yeah, very good. Mm-hmm. Times derivative with respect to x of this function, which is itself a composite function, right? So we're going to apply the chain rule here again. Mm-hmm. Yeah, very good. Now this will be equal to what? Well, good news here, the square will cancel the square root, right? So let's carefully remove this square root and the square, right? This will be just 5x. So this will be 1 over 1 plus 5x. This part looks nice. Times the derivative of this guy. But the derivative of this guy, remember, is, I'm going to write here, recall. Remember, I gave you this result, right? The derivative of square root of x. And someone is writing on the chat. In simplified form is this, right? 1 over twice is square root of x, right? In simplified form, all worked out. Yeah, very good, Herman. Herman, very good. Excellent. Marcos also. Very good. So the derivative of this, derivative of side function will be 1 over twice a square root of something, right? Following this. But that something is 5x. Times the derivative of 5x, right? Derivative of 5x. But what's the derivative of 5x? That is just the number 5, right? The number 5. Yeah, finally, look, after all this work. Excellent, Deep, excellent. Mm-hmm. Yeah, very good. Mm-hmm. Yeah, very good. So now, yeah, now let's put just all together, right? All our work together. So this should be equal to what? 5 on the top, right? 5 on the top. 5 times 1, 5 times 1, 5. On the bottom, let's put this number 2 at front, and number 2 at front, followed by this guy 1 plus 5x, or 5x plus 1, the same, followed by this square root of 5x, right? Following kind of the rule the mathematicians follow, the simple functions, the constant function up front, then linear function, then a square root of something, composite function following, right? So this should be it. Look for this among the choices, and it's here, right? It's here. Mm-hmm. Number 5. Very good, guys. Can you try number 6 to finish this up? So let's try number 6. Try this, guys. The hint is gonna be, I'm gonna write here this as the composition of three functions, right? Tangent inverse of the square root of 7x. So the outsidemost function tangent inverse, then followed by this square root function, second function, and the last function is this linear function 7x. 7x. It's a nested function, right, made of three functions. So apply the chain rule following or starting with, better said, with the derivative of the outsidemost function. Outsidemost. I see students figure this out. Very good, Deep. Very good. I think Gonka also figured this out. Very good, very good. Yeah, it's not that difficult once you get used to it, right? So, and try to remember this for your homework, guys. They're gonna be given some composition of functions, including inverse trigonometric functions. So try to recall this. All right, so see. Okay, let's do it together so we can finish this up. So start with the outsidemost function, right? I'm going to use a different notation for the derivative for the sake of variety notation. Marcus, very good, Marcus. Excellent, excellent work. Yeah, very good, very good. Yeah, it's tedious algebraically, but in the end, if you follow all your steps, you should land with the right answer, right? So derivative of y with respect to x, I'm using an equivalent notation with respect to the prime notation, right? This is the same. It's going to be equal to what? Start with the derivative of the outsidemost function, which is this tangent inverse function, right? That derivative is this 1 over 1 plus something squared. I have memorized this derivative, right? But in case you haven't, all the rest, the formulas are here in this sheet, right? It's on our website here. Notice there is a parenthesis there because often this will not be x. It will be some other function, right? Like this is square root of 7x now. Okay, so place it there. The function is square root of 7x, right? For a moment, this is the inside function, right? Times the derivative with respect to x of this function is square root of 5x, right? Which is itself a composite function, right? Very good. Now, this becomes the following. German, yeah, very good. We're headed there, right? Oh, you are talking about this. Very good, guys, that you are following, right? I was still thinking on the previous problem, but this is now 7x, right? Very good. Very good. So now we have to compute this derivative and then work this out. So let's do it. 1 over. Good news here. A square root of something squared, since these guys are inverse function with respect to each other, they cancel each other out. This is just 7x. 7x, just the radical comes up, right? Done with this part. Derivative of this guy. Recall, this is a nice result that you should always have written somewhere. The derivative with respect to x of a square root of x is 1 over twice a square root of x, right? This is in simplified form. So let's use that for the derivative of our outside function. The derivative of our outside function will be equal to 1 over twice the square root of 7x comes here inside function times the derivative with respect to x of this 7x, right? But what is this? Anybody on the chat or verbally? What is the derivative of 7x? Yeah, 7, right? Excellent, excellent, guys. 7. Yeah, very good, 7. So putting all this together, we're gonna get the following. 1 over 1 plus 7x times 1 over 2 is square root of 7x times this derivative is just 7, right? 7. All right. So 7 times 1 times 7 on the top, 7. 7. On the bottom, we have within parentheses this guy, right? The simplest function is the constant function too. So let's put it up front. Then 1 plus 7x here. And this composite function, push it to the right in the end, right? So this should be it. Look through the choices. And that is clearly here, right? Follow, guys? Very good, very good.